Hello, I'm Stuart Reid. Welcome to this course on AI testing. In this session, I'll cover some of the quality characteristics that are especially important for AI-based systems, such as flexibility, adaptability, autonomy, and evolution. ISO 25010, part of the ISO 25000 series, is an ideal starting place for considering quality characteristics, as it defines a product quality model applicable to any software system, and thus also to any AI-based system. However, not all of the listed characteristics will apply to all systems. For instance, compatibility may not apply to standalone embedded systems, and usability will seldom apply to those systems with no user interfaces. In practice, it is best to check each of the characteristics and discard those that are not relevant, rather than accidentally miss an important characteristic. The slide highlights that each of the listed quality characteristics, other than functionality, are used as the basis for non-functional testing, with the functional characteristics forming the basis for the functional testing. The presented quality model is generic, and so it is applicable to any software system. However, in this section, we will extend this model to introduce additional quality characteristics that are specifically applicable to AI-based systems. At present, ISO are working on ISO 25059, which will be a new standard in the ISO 25000 series, and this new standard, when published, will exclusively cover AI-specific quality characteristics, which should be similar to those we cover in this section. On this slide, we can see a list of the AI-specific quality characteristics covered by the syllabus. In this session, we will cover the first four listed: flexibility, adaptability, autonomy, and evolution. We will cover the remaining characteristics, which are greyed out on the slide, in subsequent sessions. Each will be covered in turn. We will consider the flexibility and adaptability of AI-based systems together, as they are very similar concepts. Both are concerned with the system coping with new situations. Flexibility is an intrinsic characteristic of a system being able to cope with new situations itself. Slightly different is adaptability, which is concerned with the ease of someone else changing a system to manage these new situations. As we can see from the definitions, flexibility is built into a system and requires no further human effort, while adaptability is a system attribute that defines how easily humans can modify the system. On this slide, we consider typical situations that would encourage us to prioritise flexibility, adaptability, or both in a system. Both are concerned with the ability of a system to deal with operational environments and situations that may not have been fully understood or predicted when the system was designed. In such a case, we want the system to either be flexible enough to cope with the unexpected situations itself, or adaptable enough so that it is easy for maintainers to update it to cope with a new situation. A specific attribute of a flexible system is its ability to identify those cases when it needs to employ its built-in flexibility. For instance, a system that changes modes based on weather conditions must be able to identify all possible changes in weather that it should respond to, and, ideally, it should recognise relevant weather changes that do occur as early as possible. Flexibility is also of specific interest when we talk about self-learning systems. Many people believe that all AI-based systems are self-learning, but this is not the case. For many systems, machine learning is used to build a model from the training data, and the resultant model that is deployed is stable and does not change once the system begins to be used operationally. This is the case when machine learning is used for safety-related systems. We do not trust that a flexible system will always change itself in a way that leaves it safe, and so self-learning systems are not used for safety-related applications. Having said that, Self-learning systems that modify and improve themselves based on their experiences are a really useful subset of AI-based systems, and in the future are likely to be more widespread. However, building self-learning into a system is necessarily more complex, and so it increases the risk of the system failing. Thus, the decision to use self-learning systems is a compromise between their potential improved performance, which is achieved through the system's built-in flexibility, and the increased risk this complexity brings. Today, commercial, non-safety related self-learning systems are available and are used in some mission-critical situations where the ability to improve from self-learning is considered important enough. For instance, there are examples of self-learning systems that work with financial markets and have a requirement to change in response to what happens in these markets. Normally, this is when the changes have to be made more quickly than they could be if the changes were made manually.